Okay, welcome back. Continuing along talking about the lift calculations, let's take a look at some of the details here. And as I mentioned, you'll see more in the PDF. So some of the simple calculations we'll attempt to do as part of the quiz is, if you know the weight of the aircraft, the area of the wings, how how big the wings are, for example, the lift coefficient. As I mentioned, it's a function of the pitch angle, the angle of attack. We can calculate the speed at which the lift equals to the weight using that equation. Now again, I'm going to warn you that these are still approximate calculations. But what is really interesting about the stuff is, even if they're approximate, you can get answers that are actually pretty good. I mean, they're not exact, and there's certainly all kinds of refinements we can make. I mean, this is not the kind of thing that Boeing, for example, would use to actually make their planes and calculate the performance for the pilot and so forth. But it's still something which is pretty good, actually. Okay, if you know the pitch angle of attack, for example, you can calculate the pitch angle given the altitude and the speed and the weight in the area. So you can ask, for example, the pilot has to decide and what the pitch angle is if he or she wants to fly at a given altitude and given speed, weight, and area, and so forth. So we'll do some of these calculations, either calculating velocity or calculating the pitch, and so forth, and fairly straightforward calculations. Now keep in mind, of course, weight changes with time, because of fuel consumption. And so that sort of complicates the issue. We're not going to deal with it really that much. And if you go back to our automobile calculations and chemistry, we made all kinds of assumptions, but still came up with a number that, something like 30 odd miles a gallon, which is still pretty good. So what this is telling you is that, and everything does not have to be really complicated. It can do fairly good calculations using simple assumptions and getting numbers that are actually pretty reasonable. Okay, so here's what we're going to take a look at. What are the forces acting on a plane? You certainly have gravity, right? The weight of the plane, which is the weight of the plane itself, the passengers, any cargo, and fuel, and so on and so forth. The thrust, and this is caused by the combustion of the fuel, ejecting the gases, and then shoving the plane forward, right? Like what we do with the automobile. The energy from the combustion creating mechanical energy and moving in this case, the plane forward. Lift, that is coming because of the difference in the pressure, essentially because of Bernoulli's equation, if you remember. And of course, drag. Like the automobile, it is flowing past air, and therefore air is trying to push it back, and so there's going to be drag. And you don't have to worry about these equations, but essentially there are ways in which you can calculate what those different forces are. And so, let's see, yeah. The question therefore comes up, it's like, is it possible, like we did with the automobile, can we calculate a miles per gallon for the for airplanes? You ask the question again, take a cross-country trip, say 200 people flying in a 737. There are actually estimates of how many miles per gallon or miles per gallon per seat, per person, for example. You can do the calculations. But those are based on actual fuel consumptions divided by the distance, divided by the number of people, and so forth. The question really is it really possible to calculate theoretically like we did for the automobile? It's a little harder because of some additional forces we need to worry about, because of the fact that for the airplane, we need to have some energy to keep it afloat, for example, in the air. It's a little complicated, but it's still actually possible to do some back of the envelope calculation. So the fuel is needed for lift and fuel is needed for drag. So what you'll see at the end of this week is a short quiz where I'll sort of walk you through step by step, allowing you to calculate, for example, velocity from pitch or pitch from velocity and so forth, just to give you an idea of how even with the simplest of concepts, as you talked about, you can do all kinds of very interesting calculations leading you to some numbers that are actually quite reasonable.